we did mostly those mixture problems, like number 5. All the homework questions were like that, number 5. But the very last example I did was an interest problem. And we set it up the same way because we had an investment and we were putting some of it in an investment at 8% and some of it at 12%. So we made a table. Remember, interest, principal, times rate, times time equals interest. So Friday's formula that we were using is amount times concentration equals the amount pure. The second formula that I showed you Friday, and I want to do another one today, is principal times rate times time equals interest. So let's look at a problem. Linda won $200 in a state lottery. She first paid income tax of 30% on the winnings. Of the rest, she invested some at 1.5% and some at 4%, earning $4,350 interest per year. How much did she invest at each rate? Okay, we've established that if you just read these problems, you probably get to the end and have no idea what you really read. Right? We have to break it down. We have to go back and go step by step. What is the very first thing that's happening here? Yeah. Did she even have the whole $200,000 when she invested it? No. It's just like you get a paycheck. Do you ever actually get all of your money? No. It's gone before it ever comes to you. So let's figure out how much money she has. So she had $200,000 to begin with, and she paid income tax of 30%. So how do I figure out what she has remaining? Okay. So if I take the 200,000 times 0.3 for 30%, what does that give me? So does that mean she has $60,000 left?
That's how much she gave.
Right, that was the tax. That's what they took away. So to figure out what she has, you have to take her amount and subtract off that $60,000. So we're really only dealing with $140,000 here. I don't need to ever think about that $200,000 again. She never saw all of that. The only thing she's seeing is $140,000. Okay, now she's going to make some investments. She's putting some in an investment at 1.5% and some in an investment at 4%. So when we have multiple things going on here, that's when we make this table. Across the top, I want you to put your formula. So principal times rate times time equals interest. So those are all the boxes we have to fill in. Your labels over here, you can call them whatever you want as long as you know what you're looking at. We're putting some at 1.5%, so I'm just going to call it a 1.5%. And the other one is the 4%. And then we had our total. Okay. Questions on the setup right here? Now we just go back to the problem, we start reading and figuring out where to put all the information. We've already dealt with this first piece. I don't want to go back to it. So she put some money at 1.5%. I didn't tell you how much, so what do we put? X. Okay, you have to be really careful here. You know, if I said she put twice as much at 4%, then we could put a 2x here. Did I say she split it in half and put some in each? No, so I can't just call this x. What else do I know that would go in this column? Remember, she had $140,000 to start with, right? So that is our beginning principal. So that is the total principal, the total amount we have to begin. Okay, let's just think for a second. If you have $140,000 and you give me $40,000, how much do you have left? $100,000. How did you get it? Subtract it. So if she had $140,000 and she put X in the first, what does she have left? Okay, now our rates. The first one was 1.5%, so my rate would be percent. You always move it back 2 places. So 4% would be. I did not tell you the overall rate of return. It's okay. Sometimes we're going to have gaps in this table. Just because we drew the whole thing doesn't mean I have to put a number in every box. So I didn't tell you the final percent. We're just not going to worry about it. We're talking about interest per year. So my time would be 1 year. Okay? Now we can just use our formula. To get the interest, we're just multiplying principal times rate times time. So we have the 0.015x, the 0.04 times 140,000 minus x. Now the last one, since I don't have that rate, I can't just multiply it. So how will I figure out my total interest? Read the problem. It tells us the total interest, so I can just write that number down. So the nice thing about these tables, if you can get that final column, your equation writes itself. You're just going to add the first two to equal the total. So 0.015x plus 0.04 times the 140,000 minus x equals the 4350. So now we have our equation. We just need to solve. So 0.04 times 140,000 to 600 minus our 0.04x add like terms. So 0.015 and negative 0.04. Negative 0.025. You guys checking me? You don't just trust me, do you? That's dangerous. subtract over your 5,600. And divide. What do you get? Use your Chromebook for a calculator if you don't have one.
50,000.
What?
50,000.
Look back, the original question was how much did she invest at each rate? So, she invested, if we look at our table, 50,000, my X was the amount at 1.5%. So she invested $50,000 at 1.5%. And for the second rate, 4%, we just have to do 140,000 minus X. So 140,000 minus 50,000, $90,000 at 4%. So tonight's homework is going to have one problem like this. Again, if you did not watch Friday's video, the last example I did Friday was one like this as well. Any other questions on that? We're going to look at a slightly different problem now. Remember, all these examples are typed up in that handout that's posted on Classroom. So if you just put example 9, if you need to look back later, you can just pull that up. Alright, Peripheral Visions Incorporated produces high-definition DVDs of live concerts. The company places an ad in a trade newsletter. The cost of the ad is $100. Each DVD costs $20 to produce, and the company charges $24 per DVD. So part A, express the cost as a function of X, the number of DVDs sold. So this one is not nearly as complex as the others. I don't have all this different stuff going on. Look back at our problem. The cost is $100, and each one costs $20 to produce. We are really just writing the equation of a line here. We know a line, y equals mx plus b. We have a slope and a y-intercept. In terms of costs, your slope is like a repeated cost. A y-intercept is a one-time thing. We can do function notation. We've learned that at this point. It says cost is a function of x, so instead of writing y equals, I'm going to put c of x equals, just c for cost. So if you're talking about the cost to the company, what is the repeated cost? The thing they're going to pay more than once? $20. That's their slope. So 20x plus, what is the one-time cost? The $100 for the ad. So there's our equation. C of x equals 20x plus 100. B. Express the revenue as a function of x. Revenue is the money you're bringing in. So I'll choose function notation. So r of x equals, when we're talking about the money they're bringing in, that's the amount they're charging per DVD. So that would be 24x. It's a repeated thing. Every time they sell a DVD, they get another $24. Do we have any lump sum payments coming in or anything like that? No, there's no mention of that, so there's no y-intercept here. It's just a 0. So our revenue is just 24x. Part C, I want to know for what value of x does revenue equal cost. That's like your break-even point. So all I'm saying, revenue, so my revenue was 24x, equals cost, and my cost was 20x plus 100. Solve that equation, so if you subtract over your 20x, divide by 4, and x equals 25. So at 25 DVDs. So that's saying if they produce and sell 25 DVDs, they have made no money, they have lost no money. Less than the 25 DVDs, they're losing money. Anything beyond that would be profit. They'd be making. I want you guys to try to set up one like this. Here's your problem. Okay, let's take a look. So we have a baker making cakes and selling them at the fair. Her initial cost was $40 and each cake cost $2.50 to make. So her cost function, C of x, what's the repeated cost? 2.5. If you put 2.50, that's fine. And she has to pay for the fare, so plus the $40. Okay, B, revenue, the amount she's bringing in. She charges $6.50 per cake, so the amount she's bringing in would be 6.5x. C, I want to know when revenue equals cost. So you just set those two things equal. Subtract over your 2.5. So for 10 cakes, that's when she breaks even. What questions do you guys have on that one? Let's try one more. So last example of the day. A company produces 10 solar heaters for $7,500. The cost to produce 20 heaters is $13,900. Part A, express the cost y as a linear function of the number of heaters x. This one is not quite the same. Did it just tell me a one-time cost and a repeated cost here? No, I have 4 different numbers in here. What is it giving me information to write? Yeah, order pairs. X is the number of heaters, Y is the cost. So 10 heaters, so my X is 10, the cost, 7,500. For 20 heaters, the cost is 13,900. Now I'm asking you to write the equation of the line. We know how to do that. We were doing that last week, earlier in the week. So find slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we get a slope of 640. Then what do? Take a point, take your slope, and we're going to plug into y equals mx plus b. So my y, 7,500, equals my m, 640, times my x, which was 10, plus b. Subtract over our 6,400, and we get a y-intercept of 1,100. So final equation then would be y equals 640x plus 1,100. B says determine the cost to produce 25 heaters. So what do? Yep. X was the number of heaters, so my x is 25. Okay, 640 times 25. What's it? $1,600. Plus our 1,100. And so then we get $17,100. And we look, that is a reasonable answer. We know to make 20 of them it costs $13,900, so 17,100 does seem reasonable. Questions for me? So we have 10 minutes left. I want to give you guys some time to try your homework. That same handout that I posted on Thursday. So the section 1.6 assignment, still on Classroom. Today we are ready for 8 through 11. So the first one is an interest problem, and then 9, 10, and 11 are like these linear ones that we were doing. So we've got time to work on that and ask me questions right